Yeah. So, hello, hi, namaste, salama. Welcome to Anuj Kumar IND. And now it's a continued through kinematics, in which we have made 3 videos also previously. And now we'll be continuing it with derivation of Newton's equation of motion, that v is equals to u plus at, s is equals to ut plus half at square, and 2as is equals to v square minus u square. Yeah, we have studied it in class 9th also, but now it's time to derive it. In ninth class we have derived it from the graphs, but now we'll derive it from integration. And you may remember that I have taught integration in the previous video of physics. Okay, so let's start with the derivation of Newton's equation of motion. And before starting, please like, share and subscribe the channel. It's really important for us to make the videos and to motivate us. So without any delay, let's start the derivation. Yeah. So our first, so when we talk about the Newton's equation of motion, we should know that here the acceleration is uniform acceleration. That means acceleration is not changing. Obvious, is not changing. You have to see the integration video. If you haven't seen it, then you can't understand it. Okay, so it's my request that please see first that video, then jump to it. Okay, so we are starting with the Newton's equation of motion. So our first equation is v is equals to u plus at. So to derive it, let's start. As we know, acceleration is rate of change of velocity with respect to time, dv by dt. Okay, I can write this as dv is equals to adt, right? dv is equals to adt. Now this is the main step. This is the main step. After it, the equation is proved. How? See, now we'll integrate both the sides. Integration of dv is equals to integration of adt. As we know, acceleration is constant, so it will come out an integration of dt and an integration of dv. Now you will say how we will integrate this. It's simple. Take here v to the power 0 dv is equals to a dt. And what will be the limits? Here it will be from initial velocity to final, and it will at initial velocity. What is the time? The time is t is equals to 0, and the in final velocity will be at time is equals to t. It can be any time, right? And so here it will be v is equals to v minus u, right? v minus u, okay, is equals to, here I can write t to the power 0 dt. Here will be 0 t. So v minus u is equals to, it will come out to t, a into t, and this turns out to the famous equation v is equals to u plus at. Hence proved. Moving to the second equation. Now, to prove this second equation, we know that velocity is equals to rate of change of instantaneous the displacement, rate of change of displacement with respect to time, right? So I can write this as v dt is equals to ds, right? Integrate both the sides. v dt is equals to ds, right? The v is now we have proved that v is equals to u plus at, so I can write it as u plus at dt integration of ds, right? It's very simple. Now what will be the limits? Put up the limits. Now the limits will be time is equals to 0 to t, right? And here it will be for the s it will be time 0 and s. ठीक है, at t equals to 0 it have reached the 0 distance, at is equals to t it have reached s distance. Okay, or displacement, sorry, right? So let's integrate it. So you must have studied the rules that we have taught you in the last video of integration. So here we will integrate it separately. First we'll integrate u dt, and here we'll integrate plus at dt. Here it will become s only, right? So here the u, right? Here we have u, right? And as we know that u is constant, u will be constant, right? If we take an that the initial velocity is always same, it cannot vary as it is a single quantity, right? So u will come outside, and here it can become t to the power 0 dt plus a will come outside, t dt, its multiplication is equals to s. So it will turn out to, if you don't forgot, so please put up the limits, 0t 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 0t. Okay, so it will turn out to ut plus a into t by 2 and t square by 2, as we know that it is n plus 1 upon n by 1, and here it will be 0t is equals to s. It turns out to again a famous equation. It will become half at square is equals to s. So it have formed s is equals to ut plus half at square. S is equals to ut plus half at square. And here we have proved v is equals to u plus at. Okay, so now the last equation, what's that? The simple one, 2as is equals to v square minus u square. It's my request, pause the video and try it once by yourself. Okay, so you can pause the video, I'm continuing it, right? So remember when I taught you the chain rule in differentiation, so we got a result that a into dv by ds is equals to, oh sorry, v, here it will come v into dv by ds is equals to acceleration. If you don't remember it, please go back to the differentiation lecture and then study it and then come here, no problem. Okay, so it was we have proved it in the chain rule. Okay, so just go there and revise it. So what will it become? So v dv is equals to ads is equals to ads. Okay, no problem, integrate them. So v dv is equals to integration of ads. What will be the limits? 0 s and uv. Simple, yeah. So integrate it. What will it become? Remember that the power is 1, so here it will become v1 plus 1 by 1 plus 1 minus u1 plus 1 upon 1 plus 1 is equals to, acceleration is constant, so it will come out, no problem, it will remain like this only, as, it will become as. So v square minus u square upon 2 is equals to as. So v square minus u square is equals to 2as. Now it's again turned out to a famous equation. What is it? You know, the third equation of motion by Newton. V square minus u square is equals to 2as. Okay, so we have proved all the three equations of Newton's equation of motion. So thank you very much, and meet you in the next one. Shabak khair.